Hello dear students, welcome to your YouTube class. So in the last live class I had explained you all doubts relating to algorithms. So all the algorithms which all we are solved till in the previous class, those all are relating to your sequential method of your algorithms. So what is the sequential method of algorithms is, in a sequence one after the other each step is executed. That is what we call it as sequential method of the constructions. So when all you are writing any program or when all you are solving any program or a problem, then we have to refer the construction methods. Totally there are three types of your construction methods. The first one we have is sequential method. These in detail you learn in the next chapter, but timing as at this point is coming in the explanation, I'll cover it. Second one is called as condition or conditional. The third one is called as looping. Okay, so any given problem can be solved in these three methods, which are called as constructing methods or the constructing types. Sequential means the program in sequence, stepwise it is written. The first statement, second statement, third statement, fourth statement. All the statements which are there in your program are executed one after the other in sequence without any break. The first statement will be executed, next second, next third, next fourth. Like this in sequence, one after the other, each statement will be executed. That is your sequential. Conditional means we execute few statements. After that, we have to check some conditions. If it is correct, then the set of the statement will be executed. If it is wrong, another set of the statements will be executed. Means when it is correct, when it is true, only these part will be executed. And we'll skip the false part, means when wrong part will be skipped. And if it is wrong, then only this part will be executed, this part will be skipped. So here we decide based on the condition. If it is true, we'll come this side and we'll execute these part of the statements. That time this part will be skipped. And if it is wrong, we come to this side and only execute this part of the statement, this part is skipped. Like this, we take the decisions based on this condition, where one part will be skipped and only another part of the set will be executed. That is what we call it as conditional construction. Next comes is looping. What we do in the looping is the same set of the operation. If you want to perform many times, then that time we use the looping technique. For example, I want to print the numbers from 1 to 100. So what I am doing, I am printing the numbers. How many times I am printing? I am printing from 1 to 100 means 100 times I am performing the print operation. What I am doing? I am performing 100 times print operations. So rather than writing print statements 100 times, what I do is I use a looping technique, where in few statements, like 2 to 3 statements, I can use and I can perform that print operations. So where 100 statements are reduced to only 3 to 4 statements, so other 96 to 97 statements are saved. Those many lines are saved. Done. That we do in the looping. So like this, we have the different constructing sequence. So now what all the algorithms you are written in these few 4 to 5 classes, those all are based on your sequential. Actually, I have to explain based on your conditional and looping, but right now you don't have any idea relating to the conditional and looping. It will be very difficult for you all. So when I deal these conditional looping construct in the next chapter, we'll write few programs in other chapters, then I'll tell you how we can write the algorithms and the flowcharts on your conditional and looping. Timing in this chapter we'll learn all the sequential algorithms and all your sequential flowcharts only. Okay, so we'll not create any confusions based on your conditional and looping. Later, when you learn all the theory relating to your conditional and the looping, then we'll study relating to the algorithms and the flowcharts also. Fine. So timing, you just remember the meaning of sequential, conditional and the looping. So before starting closing your algorithms and starting with your flowchart, I have to give you few points. Okay. So you have to remember some points is when all we are writing your algorithm, we do some analysis. Is it a best algorithm? Is it a average algorithm? Or is it a worst algorithm? So how to analyze that the given or the written algorithm is best, average or worst is based on 2 points. The first one is called as space complexity, and the second one is called as time complexity. The first one is called as space complexity and the second one is called as time complexity. If you remember, in one of the class I had explained this space complexity and time complexity. One more time explaining, just remind that point. Okay, the space complexity means the amount of the memory needed by the algorithm complete its runs, means how many steps we are writing in that algorithm, how many steps we are writing and how much the memory space is required to store that particular algorithm. That is the space what we call. Few algorithms I'll write in 4 to 5 steps. Some more algorithms need 10 steps, some needs 12 steps, some needs 15 steps, some needs 20 to 40 steps. Okay, like that, how much the memory is required of the computer to store your algorithm in the computer. That is your space complexity. Next, the time complexity means the amount of time the algorithm need to complete its execution. So how much time is required? 1 hour, 2 hour, 3 hour, 15 minutes, 30 minutes, like that. How much time you are taking to complete that algorithm, that is called as your time complexity. Now based on how much the memory you are occupying, how much the time you are taking to complete that algorithm, we write the best algorithm, average algorithm. We divide the algorithm into best, average and worst. What we call it as best case, average case and worst case. So when it is called as best case is when you are occupying less space and less time. Less space and less time means you are occupying less space of the memory and less time to complete your algorithm. Required only that much. If it is covering in only 4 steps, you have to finish in 4 steps. If it is required only 15 to 20 minutes, you have to finish in 15 to 20 minutes. You should not take more than 4 steps like 10 or 15 steps and not more than 20 minutes like 1 hour or 2 hours. It is a wastage of time. Then, so this is not called as the best case of your algorithm. It is called as worst case of the algorithm. Then, so how much the best time is required, how much the best space is required to store that algorithm. If you are covering the algorithm in that memory in that time, then it is the best. Living best, second one comes is average. If it is not possible to cover in that much time and the memory, then you can go for the average, a little bit increased space and little bit increased time. If you are taking, then that will be the average case. If it is you are unable to cover in 4 steps, you can go for 6 to 7 steps, no any issues. If you are unable to cover into 15 to 20 minutes, you can go for 30 to 35 minutes. So you are increased but not more, a little bit. So that is the average case. Next comes is average, worst case, where it can complete in 4 to 5 steps, 15 to 20 minutes, average 30 to 35 minutes, 6 to 7 steps. Rather than that, you are taking 15 to 20 steps and 1 to 2 hours to complete that algorithm. So that case will be your worst case, we call it as. That case is your worst case of your algorithm. Then, so how you are giving the solution to your algorithm, what the memory space you are occupying and how much time you are taking to complete that algorithm, it will decide your algorithm. Is it best algorithm, is it average algorithm or is it a worst algorithm? Then it is all based on your space complexity, time complexity. The less space, less time means best. Normal space, normal time is average. More space and more time means that is the worst case. Then these are all the points you have to remember relating to your algorithm. Fine. So today I'll close your algorithm. The sequential algorithms were written. I guess almost many sequential examples I had taken till now. Again, if you have any doubts, let me know. I'll clarify all your doubts. Now I'll begin with the next part of your designing, that is called as your flow chart. We are discussing the steps to solve your problem using your computer, don't forget. So we had covered your definition, we had covered the analysis, now we are covering the designing. In designing we are done with the algorithm, now we are moving to the second designing part, that is called as flowchart. So we know that algorithm is nothing but the step-by-step procedure to solve your given problem, where your flowchart is nothing but the diagrammatical representation of your algorithm is called as your flowchart. What we are doing in the algorithm? The given problem we are solving, we are giving the steps to solve, the solution to solve that given problem, but stepwise. Step 1 this, step 2 this, step 3 this, like this. Stepwise 1, 2, 3 like that. We are in sequence solving the problem. The same algorithm what you have written, now you are representing that algorithm. The algorithm is written in the steps. The same you are representing in diagrammatically, then that is called as your flowchart. Algorithm we are representing in the format of diagrammatical way, that is your flowchart. Fine. Note down the meaning of flowchart, that can be asked for 1 marks. Meaning, or which is also called as definition. So the diagrammatical representation of an algorithm is called as, or is known as, flowchart. Then what is your flowchart? The stepwise step procedure what you are written in the format of algorithm, that you have to just display in the format of the diagram, that would we call it as your algorithm, flowchart. Fine. Now before knowing what do you do in your flowchart, how to write your flowchart, a little bit theory we have to cover in this flowchart. Then there are mainly 2 types of the flowcharts we write. There are mainly 2 types of your flowcharts we write. The first one we write is program flowchart. The second type of the flowchart we have is system flowchart. There are totally 2 types of the flowcharts are available. The first type is program flowchart and the second type is your system flowchart. So what do you mean by program flowchart? The program flowchart will give you the flow of the operations or the process or the calculation what you are doing in your algorithm diagrammatically. We are already written the steps, the process, the input, output and the calculation, everything in your algorithm. The same steps we are converting, representing in a diagrammatically way in your pictures, that is your program flowchart. The next one comes is your system flowchart. What we are doing in your system flowchart is, here in your system flowchart we are trying to give the overall view of your computer system, how it works, how the problem is taken inside, how it is executed, how the data is transferred from one unit to another unit. Like that, each system's diagram we are displaying. That is what we call it as system flowchart. What example I can give you for your system flowchart is your block diagram of your computer. If you remember your block diagram of your computer, what we did in your block diagram of computer, this is your input unit, this is your memory, this is your CPU, this is your output. So we had displayed how the data is transferred from input to memory, how the data is transferred from memory to CPU, from back to CPU to memory, then memory to output. So how the data is transferred, how this system is working, how your system, that is your computer system is working, that we had shown through the diagram. So we call it as a system flowchart. Like this, any system, how it works, the working of the system, if you are representing through the diagram, then that is called as your system flowchart. That is what we call it as system flowchart. Fine. So system flowchart and your program flowcharts are mainly 2 types of the flowcharts. In program flowcharts, what we are doing, the algorithm what we are written, we are transferring into your diagrammatical way. And system flowchart means the system's working or the processing we are showing through the diagram. That what we call it as your system flowchart. Fine. Next we'll see some of the importance of your flowchart. Why we have to study the flowchart. What we'll get using your flowchart. That we'll see importance of the flowchart. So what all the importance we have regarding to your flowchart is communication is very easy. The first one is communication. So what happens is in your algorithm, what all the process we have to carry out, that you are written in the steps. If anyone knows relating to the algorithm, that person only can able to understand everything relating to the algorithm. Means how the stepwise step the data flow is going on. For example, I had written here something in step 1. So what happening in step 1, what happening in step 2 is known to me because I have the knowledge relating to the algorithm. If anyone comes and start reading the algorithm, they just read the steps, but how exactly the data is flowing from one step to another step, that is unknown to them. But if you see the diagram, see, this is the diagram: input unit, memory unit, output unit, and CPU. Okay, so connection I had given from IU, that is input unit to memory unit, memory to CPU, CPU to memory, then again memory to output unit. So if you see the diagram, the arrow marks the connection, easily you can recognize, easily you will get to know that how the data is flowing from one unit to another unit. So the communication is very easy through your flowchart. What do we say? The communication is very easy using your flowchart. The second one is effective analysis. If you want to analyze the process, how it is taking place, how the input is doing, how the processing is taking place, how the output is displaying, where the calculation is there, where we are starting, how we are stopping the process, what data is transferring from where, that all analysis is very easy through your flowchart. Next we have is efficient coding. Efficient coding means if you see the flow of the diagram in your flowchart, it is very easy to know how to do the programming, how to write the program. So we can write a good program by analyzing your flowchart. Like this, we have many importance of your flowchart. Like the proper debugging. If you did any mistakes and you want to know where that mistake, where that error is there, so that analysis of error, finding the error and rectifying that error is very easy if you refer your flowcharts. If you want to create the documentation, then that is also very easy by referring your flowchart rather than your algorithms. Then, so like this, we have many more importance relating to your flowcharts. It gives you the good communication, easy to analyze, easy to code, easy to debugging. Documentation is very effective if you refer your flowcharts. Like that, the many importance are there. You remember few importance where you can answer it for 2 to 3 marks. Right? So these all are the theory part which we had covered, importance and the types of your flowchart and the meaning of your flowchart. Next we'll study relating to, before writing your flowchart, we have to study the symbols or the notations used in your flowcharts. So I'll give the title, note it down, flowchart symbols. Sometimes these are also called as notations. Sometimes these are also called as notations. So we know that the flowchart is nothing but the diagrammatical or graphical representation of your algorithm. So to represent any algorithm diagrammatically, we have to use some notations. So which all the notation you use? There are many notations which are there in your flowchart, but exactly which notation or which diagram or which symbol is used for what purpose, that is the main thing you have to learn. Fine. So you may get 2 marks or 3 marks question, 2 marks or 3 mark question to write the different symbols or the notations used in your flowchart with its name and the meaning. Means meaning is for what purpose we are using, name of the symbol, what it is called, and you have to draw that symbol also. Then for this, what you have to do is make 3 partitions of your page. The first one will be name of the diagram or the symbol. Next we have to draw the symbol, and The last one is meaning of the each symbol. Like this, make 3 compartments. So the diagrams, now the symbols I am drawing with the pen in the video, but you have to draw the symbols using your pencil, because the flowcharts are always drawn using your pencil, not using your pen. The flowcharts always has to be drawn using your pencil, not with your pen. If you draw it with pen, even though your flowchart is correct, you'll get 0 marks. Inside the flowchart, inside the symbol, what are the contents you are writing, that also should be with the pencil. You are not allowed to use pen for your flowchart. Fine. So note it down. The first notation what we are using, the name is oval, O-V-A-L, oval. How to draw that symbol? The 2 parallel lines and a curve. 2 parallel lines and the curve. The meaning is beginning and end. We use it at the beginning step or at the end step. Means the start and stop should be with the oval symbol. In your algorithm, how you write the algorithm? The first step is always the start and the last step is always the stop. So how to denote that start and stop here in the flowchart? There should be the oval at the start. You have to write inside this as start. Don't draw right now, but I am telling it. You have to write start, and at the stop you have to draw again one more oval, and in that you have to write the stop. Done. I'll take one example and I'll let you know how we write it. Done. Timing, oval, you just remember the name, oval, diagram, symbol will look like this. For what purpose we use? We use it for the beginning and end, means to write start and stop. Fine. The second one we have is parallelogram. Second one, parallelogram. So how to draw? The same, a little bit cross and these cross lines like a rectangle. Not exactly rectangle. Rectangle will be the straight line. This is the cross lines. Rectangle is used for another purpose. So don't get confused between your parallelogram and the rectangle. Rectangle you use it for another purpose, different. Here this parallelogram is used for different purpose. Okay, a little bit cross should be there. So this is used for input and output. Input or output. For what purpose we use? When all you are writing the input statement, read statement, and when all you are writing the output statement or the print statement, that time we use this symbol called as parallelogram. Understand? Oval is used for start and stop. Parallelogram is used for input and output. Next comes is your rectangle. Next comes is your rectangle. So 2 parallel lines, rectangle is known to everyone, and straight line. Okay. So if you not make parallelogram cross, it looks like rectangle, and the purpose of using rectangle is totally different than your parallelogram. So if you do any mistakes in these 2 shapes, then you will get 0 marks. One definite question you will get on your flowchart for 5 marks or 3 marks. You have to draw a flowchart. So you lose your 3 marks and 5 marks, even though the logic what you are using and content what you are writing inside is everything is correct, even though you lose your marks if you do mistakes while drawing. Just see, the edges are cross and sharp for your parallelogram, where we have the straight line edges for your rectangle. Fine. Your parallelogram is used for input and output, where your rectangle is used for process or for calculation or for assignment. If you want to do any process, if you want to show any calculation, or if you want to assign any value, that in these all the 3 cases we use rectangle symbol. Fine. The next one, fourth one comes is rhombus, R-H-O-M-B-S, rhombus. The diagram is like a diamond, straight lines. The diagram is like diamond. This is used at the time of decision, or which is also called as branching. Means when all you are checking the conditions, no? While explaining that conditional construct, I had used the same symbol. Fine. So whenever you are checking the conditions, that time that condition is checked in this rhombus symbol. Done. That is what we call it as decision and branching. Next comes is preparation. Next symbol is called as preparation. So how it is? It is your hexagon. This is your hexagon. This is used for loop. In looping, we have different types: while loop, do while loop, and for loop. That we'll study in the coming classes in the next chapters. So that time I'll tell you when we use this. So just timing, remember, when all you are showing the for loop in a flowchart, that time we have to use this hexagon, that is called as preparation. Okay? Next we have is predefined process. Predefined process. The name of the diagram. Symbol is rectangle but double lines connected, which is for subprogram. So we write the programs. If you feel that that program is very lengthier one, so we divide that programs into different many subprograms. So when you are noting that it is a subprogram, then that time we use this predefined symbol. Fine. Next we have is connector. The small circle, it is used for connection. So what happens if the flowchart is very big and I am unable to fit that flowchart in one single page, then what I do is the another part I'll draw it into the next page, or else if here the half part and next the half part, or next continuation, like that the connection if you want to give, then the small circle is used. The small circle is used. Next, to connect these all the symbols, we use arrows. The last symbol is arrows. To show the flow of the diagram, for that we use these arrows. All direction arrows, left, right, top and bottom. So this is used for control flow. Control flow means how the data is flowing from start to input, input to calculation, branching, decision, from one step to another step. How the data is flowed, that we have to show. For that purpose, we use these arrows. Fine. So these all are the symbols which are used in your flowchart, which are also called as notations. You will get this question for 3 to 2 marks to write your different symbols or the notations used in your flowchart. So what you have to do is you have to write the name, particular symbol and the meaning. Everything you have to cover it. If it has been asked for 2 marks, write the 4 names, 4 symbols, 4 meanings, and for 3 marks means add 2 more. At least 6 you have to write it. How much? At least 6 you have to write it. Done. So in the today's class I had covered your flowchart meaning, theoretical part, importance, types of flowchart and the notations and the symbols. So how to draw your flowchart and all will start from the next class. Before starting with next class or before watching your next class video, you be prepared with your notes and the symbols. Without the symbols, you are unable to understand the flowcharts. Fine. So the other things we'll see in the next class. If you have any doubts regarding the today's class, let me know. I'll clarify your doubts. Thank you.